All right, everybody, we are back. We have Cam talking about My House Runs on .NET. You did an awesome job last year showing all the awesome things you were doing with the microcontrollers and Raspberry Pis and all the sweet things. So we can't wait to see what you have store on for us this year.
Oh, wow. So, I have to live up to the expectations, huh?
Of yourself. You dropped the mic once, you got to do it again.
So in the future, I need to make sure I don't do nearly as well.
Right.
Like Javier said, my name's Cam Soper. I'm a senior content developer here at Microsoft. I'm just going to jump right in with some slides. There we go. So, if you're anything like me, you have a ton of devices running in your home network that you plug into your house and they do house stuff, home automation stuff, IoT devices. I have a ton of these devices. I have switches, I have contact sensors, temperature sensors, humidity sensors, relays, thermostats. I have the gamut, and they talk on all kinds of different, all types of different protocols. Some use Wi-Fi, TCP/IP over Wi-Fi. Some use Z-Wave and Zigbee, which are proprietary home automation protocols. So I have all of my devices at home centralized through a home automation hub. And there's lots of different home automation hubs. There's SmartThings, there's Casa, there's used to be Lowe's Iris. I landed on Habitat Elevate. Now, like most home automation hubs, Habitat Elevate is a device that is the whole purpose is to integrate and orchestrate all your TCP/IP, Z-Wave, and Zigbee IoT devices. Now, one of the main reasons I went with Habitat is it's very similar to SmartThings. It was actually started by former SmartThings engineers. So that means it has broad market support. There's lots of devices and apps and stuff that you can make work with Habitat. Maybe it wasn't designed for Habitat, maybe it was designed for SmartThings, but you can get it working with Habitat pretty easily. And then on top of that, SmartThings has a really great open source community that a lot of that open source community, when Habitat became a thing, picked up and went to Habitat. So there's this whole open source community that shares device drivers and automation code. One other advantage of Habitat Elevate is that it does local execution. This is an advantage over SmartThings, where SmartThings is all cloud-based. And not all cloud-based, mostly cloud-based. And the final reason I love Habitat is it has a really easy RESTful API I can interact with. I'm going to show you that here in just a second. The downsides to Habitat. Well, just like SmartThings, it uses an obscure programming language. Not many people have heard of it. It's called Groovy. Usually when I give this talk, there's always a few hands that raise that say, oh yeah, I know Groovy. To me, it looks, I'd never heard of it before. To me, it looks like Java and Python had an ugly baby. I'm not crazy about it. Along with that obscure language, we have a real lack of tooling. Habitat has kind of an integrated integrated IDE in a browser, and it doesn't have anything really as far as features go, including debugging. There's no debugging. So if you need to write code, like custom code for Habitat, and not just like the built-in apps, there's no debugging model. So you just have to rely on logs. But you might remember I mentioned a little bit earlier that Habitat has a really cool RESTful API. I'm going to take a look at that real quick. So digging into the apps installed on my Habitat, its API is implemented as an app that whitelists the devices that are available to it. And then it just exposes everything via a RESTful GET request. So I'm going to paste in this URL into Postman, and it gives me a list of devices. If I append a device ID onto the end of that URL, it gives me the details for that one device. And then I can append commands. Like, for example, I can say on and turn my bulb on. Ta-da! Or I can append off and turn it off. Okay, so I've got this really great mechanism that I can use to query the Habitat device for information on my various IoT devices that are integrated into it. And I can send commands. I can turn things on and off and set levels and so forth. What about getting notified from Habitat? Is there any great way that I could set up a process that could get notified when things happen in my Habitat network? Well, it turns out there's an undocumented feature. And that undocumented feature is a WebSocket. I've got a little browser extension here that shows that if we attach to this WebSocket, we get events surfaced with the type of event, the value of the event, in this case open or closed, and the device ID that caused the event. All right, so I have an API that I can send commands to and query information from, and I have a WebSocket that I can attach to and watch for events. So inspiration struck. I realized that I could use .NET Core to build a framework around Habitat's Maker API and that WebSocket, the event socket. This would enable me to use .NET's mature tools like Visual Studio, give me full debugging support, and enable me to consume NuGet packages, as well as give me a platform on which I could build anything I could imagine. I could integrate with Azure, I could integrate with whatever devices I wanted. I call this project Puppet. Now, I'm not crazy about the name Puppet. I was originally going to name it Puppet Master. The problem was that whenever I would commit code to GitHub, I would type git push puppet master master, and I'd hear Metallica. Right. Okay. So now that I've gotten that out of my system, let's talk a little bit about Habitat Works. Not Habitat, Puppet, rather. So when Puppet starts up, it connects to Habitat over that WebSocket I showed you earlier, and it starts watching for events. Now, here comes an event. The front door opened. So that's going to be a contact sensor. That's sending, it's the type of event is contact, and it is sending a value of open. So Puppet is, Puppet's watching that WebSocket, and when it sees a contact event from the front door that says open, it looks in puppet.automation.dll. I have this assembly, this class library that it reflects over, right? It uses reflection, and it looks for any class that implements an interface I call iAutomation that also declares through attributes, hey, when the front door experiences a contact event, I want to know about it. So it finds all the automations that do this. Here's an example. Puppet.automation front door stuff, and it calls that handle method. It calls the handle method that's implemented by iAutomation. Right? Calls it. It's a task. It sets it up as a task and lets it run to completion. Now, while that task is running to completion, it can do all kinds of things. Right? It can interact with Habitat over the Maker API. It can go out to Azure, AWS, other IoT devices, wherever. It can do whatever you can do in .NET Core, you can do in one of these in this handle method. So it sits there and runs to completion. And running to completion means it could mean sub-second, or it could mean 30 minutes or an hour even. Right? We might just want to wait to see if stuff happens. If we're in a wait condition, and another event comes through with that same contact sensor, we're going to fire off the same handle method. It's actually going to kill the one that was already running. It's going to cancel it in flight, kill everything it's doing, and start up a new one and let that one run to completion. All right, so let's see it in action. I have here in Visual Studio. Let's look very quickly at my project. This is the Puppet project. It's these three projects right here, and then I have another one to demo today. Puppet Executive and Puppet Common. Puppet Executive is like the it's the brains. It's what handles listening to the event socket, and it's the program.cs that does all the work. Puppet.common is shared class libraries that go across Puppet.automation and Puppet.executive. And Puppet.automation is where we do all the neat stuff. This is where we just add classes. Here, I'll show you a really simple one. This is about as simple as it gets. This is a automation that when I open a contact sensor, turns on a bulb. So right off the bat, we've got this class. All it does is implement this automation base class. Automation base implements iAutomation, and then it adds a few other things. It does some stuff in the constructor, initializes some fields, and generally makes life easier for me. The other thing that we do is, you see I have an attribute up here called trigger device. And that trigger device is specifying two things. The first thing it specifies is what I call the mapped name of the device. I have a JSON file here that is a map of friendly names to device IDs on Habitat. So my multi-sensor that I'm going to use for demoing here is device ID 2. And then the other thing that we tell it is what capability we're looking for. So if it's a contact event, and if it's a contact event, it's going to be open or closed. If it's a motion event, it's going to be active or inactive. If it's a switch, it's going to be on or off. All right, so we implement automation base, and we have an attribute that tells Puppet, hey, this class, this is interested in multi-sensor events that involve contact. All right. So the very first thing that happens when this class gets newed up, you notice we've got a switch relay device. I call it a switch relay device. It's just on or off, right? This means a device that supports on or off. So we have a switch device here that I call bulb, a field. And I have a method called init devices. Init devices is actually an abstract method inherited from automation base. It gets fired off before anything else, and the whole idea is that we're going to init our device fields. So you can see I have a hub field. That hub field represents the Habitat collection of devices, and a method called getDevice by mapped name. Return it as a switch relay, and the name is demo.bulb. So that gives us a reference to our bulb. Why am I doing this in init devices and not in the constructor? Well, you'll notice getDevice by mapped name is awaitable. You can't call awaitable code easily from a constructor, so I made an init devices method that gets called before handle. All right, so then the handle method. This is what iAutomation brings to the game. And iAutomation, like we talked about, implements this implements handle, and handle goes off and runs to completion. And we have an object that represents the event that triggered this, right? That's handled by the base class. If that event is an open event, in other words, if it's open as opposed to closed, we're going to turn the bulb on. Otherwise, we're going to turn it off. All right, so let's run the code. I'm going to pop this up to full screen, and then I'm going to work a little movie magic and give you an overlay. All right, so here's my multi-sensor right here. This is the device ID. Sorry for the lighting. My window's right there, and the sun's shining right in. So when we open this, my bulb should come on. Sometimes it has to warm up. And it was giving me trouble earlier today, too. Luckily, this is the only demo I have that depends on this. Come on, wake up. Oh, there it goes. And the bulb should come on. Bulb comes on. All right. And then bulb goes off. We'll close it. Bulb goes off. There we go. So that's the super useful, super basic use case, rather. But let's expand on that just a little bit. This code is very similar to code that I use in my house. So I have a walk-in pantry, and I've got a light in the pantry and a light switch, and I've replaced that light switch with a Z-Wave enabled light switch. So the idea is that when we open the pantry door, we want the pantry light to come on. Well, that's easy enough, on and off. We've already got that code written. But there's a problem, and that problem is teenagers. I have them, and I can't get rid of them. So they leave the door open all the time, and I want the door closed. So the way I've accomplished this is I actually have a public address speaker. Remember I mentioned Habitat has a great open source community. And one of the great things about that open source community is that they do all kinds of neat stuff. And Habitat supports text-to-speech through premium Sonos speakers. The community said, yeah, that's not good enough for us. And they invented a mechanism that you can use to actually send text-to-speech to good old-fashioned VLC. So we'll just test it right now.
Test.
test. There we go. Let's give it another test. Actually, I was thinking about forming a band with this text-to-speech.
Check baby 1 2 3.
Yeah, I think it'll be fine. All right, so I've got that speaker device. And what we're going to do is we're going to make a field to hold a reference to it. Whoops. And there's our initializer. And down here, we're going to add just a little bit of code. I've got a method that's part of the base class called wait for cancellation async, where it'll wait however long we want it to. In this case, I'm going to say 5 seconds. In the real world, I wait 5 minutes, but for demos, we're going to say 5 seconds. And then we're going to speak, please close the door. All right, let's see what happens. There we go. Hopefully my sensor cooperates this time. Come on, hurry up, connect to Habitat. There we go. 1, 2, 3.
Please close the door.
There we go. All right, so let's do as we're asked. All right. What if we close it? If we close it before, remember we have that wait in there. We're waiting 5 seconds, right? So what happens if we close it before the 5 seconds? So open, bulb comes on, close it. Do we hear anything? We hear nothing. So the running task was canceled during that wait. All right. So as you can imagine, that announcement speaker that I have a Raspberry Pi sitting out in my kitchen that's connected to a speaker. It runs VLC, the command line version of VLC, and it just sits there 24/7 and is my announcement speaker. And as you can imagine, it's a handy tool, especially if I have kids, which I do. I work from home, and one of the problems working from home is it's hard to get quiet. Frankly, sometimes I'm in a meeting or I'm giving a talk like this, for example, and they're being noisy. Usually it involves WrestleMania. Usually I can hear sounds from the kitchen. Hulkamania, brother! You know, I don't know. I don't know what's wrong with them. I've given up. Anyway, I have switched to this display. I have a little remote control like this. Here we go. There we go. Now we can see it. I have a little remote control just like this one with 4 buttons, and they each can be pushed or held. So there's pushed events and held events of values 1, 2, 3, and 4. So I have some remote control code. This is the actual code I use on my home network right here. Let me switch back to my, there we go. So this is the actual code I use on my home network to drive a remote just like that. You can see we are watching that remote for both the pushed and held capability. And it's actually a pretty simple, so there we're knitting it. It's a pretty simple handle method. It's just a switch. I'm using C#8's tuple evaluation here for the switch. So we're switching based on the value and whether or not it's a button pushed event, because I said we're watching for pushed or held. So logically, if it's not pushed, it's got to be held. And I've got 5 different phrases here that I can speak. One, if I just push button 1, your father requires quiet, please. All the way down to I can push button 4 or I can hold button 4. And I think I'll just show you what those do. All right. Connect. Okay. So we'll push button 1.
Your father requires quiet, please.
Okay, so generally that gets what I need done. However, sometimes I have to resort to pushing button 4.
Whatever you are doing, it is frustrating your father. Please correct it now or there will be consequences.
And if that still doesn't get them to shut up, then I have to hold button 4.
I said, there will be consequences. Big consequences.
All right. So that's just kind of scratches the surface over some of the cool things that I can do with Puppet. I think probably the coolest use case, though, has to be building my own IoT devices and automating them. And let's actually look at an example of that. This right here is a garage door controller. It doesn't look like it yet. This is I actually took this picture yesterday. This is a Raspberry Pi with a little breadboard that I soldered together. All that breadboard does is it just exposes some pins in a certain order on a header. That's all it does. And I've got it connected to a relay. On the other end of that relay, I've wired it into my garage door switch. And there's the device as it sits on top of the refrigerator in my garage right now. So we've got that relay connected to the garage door. Now, the idea is that I can, just like pushing the button, I can essentially automate pushing the button, right? I can close that circuit and cycle the garage door. So the way this garage door opener device is going to work is I've got a virtual garage door driver that I've written in Habitat and a physical contact sensor on my actual garage door. Now, when I open the garage door, like if I go push the button, or if I push, I've got a remote here that I can push too. If like in my car, like if I come home and I push the button in my car, the garage door opens, the relay sensor flips from closed, the physical sensor switches from closed to open. Okay? Puppet sees that, right, through the event socket, and it goes to my virtual garage door driver, which previously said it was closed, and now says, hey, you're open. It calls a method on it called confirm open. It says you're open now. So it flips its status to open. Now that handles if I push the button, if I manually open the garage door. But what if I want to send a command to Habitat through the API to cycle the garage door? So I'm going to send a close command. So if I send the close command, what's going to happen is when I send the close command to my virtual driver, it's going to set its status to not closed, but closing. Puppet is going to watch for an event called closing. And when it sees that closing event, it's going to communicate with the Raspberry Pi and say, hey, cycle the garage door, which cycles the garage door. And then the same flow that we saw earlier happens where we flip that contact sensor to closed. Puppet sees that and notifies the garage door that, hey, you are indeed actually closed now. All right, so I know I'm running low on time. I'm going to do this demo quickly, and hopefully we'll still have time for a question or two. So I'm going to drop this project, this class out and bring these two in. The first thing I'm going to show you is just my remote control. I just reconfigured it. So now just button 1 and 2, open and close respectively. All right. Let's show you the virtual driver real quick. This is Habitat code that I had to write. It's groovy, it's ugly, I don't like it. But you can see that we are basically declaring here at the top that we implement contact sensor and garage door functionality. In other words, we support open and close commands, and we also support open and close statuses. And we also define our commands confirm open and confirm close that I talk about. And then down here is just the implementation of all that. There's really not a lot of logic. It just does exactly what I said on the slide. Let me go back to my actual garage door. There it is. We're going to put him down. Whoops. Nope. I don't know where I wanted to put him. He just wanted to go away. Now, Windows, right, down. There we go. I want him down there. We're going to leave him right there. This code up here, the garage door controller Habitat code, or Puppet code rather, it watches that contact sensor that I told you about. It also watches the garage door for door capabilities. Remember I said we're watching for opening or closing? That's what we're watching for. I also have another attribute here called run per device. Run per device says, okay, we're going to allow multiple instances of this handle method, one per device that's listed here by the trigger devices. That was just so I didn't, end up with like a race condition. We init the virtual garage door controller. What we're watching, but remember we're watching the garage door contact for contact events, and we're watching the garage door for door events. So down here in the handle, we say, okay, if we're not talking about the garage door, so we're talking about the sensor, right, the open or close sensor. If it's an open event, we send confirm open to the virtual driver. Otherwise, we send confirmed close. And if And the other case, if it's a door event, if it's opening or closing, then we just send a cycle command to the Raspberry Pi. And that Raspberry Pi command, the way we're doing that is we're just sending a message to Azure Service Bus, right? Open Sesame. And then the Raspberry Pi code over here, scrolling down, getting to the good part, is if the message is Open Sesame, we cycle the door for 3 seconds. I cycle the relay for 3 seconds, which tells the you know where I'm going with this. All right, let's run this. And as a special treat, we have my actual garage. This, whoops. I'm going to put that up there, and yeah, no, what? Change my mind. I'm going to put that down there. Nope. Stop. Window management is hard, y'all. There we go. We also have my overlay down here. So let's test it out. The first thing we're going to do is I got this remote. This is just like the one I have in my car. I'm going to push the button. All right, the garage door is opening. Habitat should see that. It does see that. And you can see down here on the lower right, down here where I've got my mouse, it now knows the garage door is open. What about going the other way? Well, remember the code I wrote, button 2 should close it. So let's hit button 2. If you watch the window in the upper left, that is the Raspberry Pi code, and you're going to see where it gets the message. Cycling door, and there goes my garage door. And that, ladies and gentlemen, is our presentation for today.
The choice of music is spot on, sir.
Sorry, Javier, I can't hear you.
This choice of music is spot on.
Thank you, sir.
So, believe it or not, we don't have any questions because everybody, not because people were just like, "Oh my gosh, this guy rocks." Again, you pulled it again, sir. Like last year, we were like, this is amazing." People were wondering where the code is on GitHub. Do you have that something right there, or is it proprietary?
So I'm gonna throw that slide. Oh wait, audio. You get to hear the music again.
Nice.
I'm throwing the slide up right now. It's github.com/camsoper/puppet. Or if you take a snap of that slide real quick, that QR code will get you there.
Sweet. Awesome. Thank you so much, Cam. This is a great presentation, like always. I really appreciate taking the time to share your skills and your passion for all this with us. So everybody, we have Aaron coming up talking about actors and aka.net. So we're going to switch to this to the slate here. Call him up and we'll be right back. So if you don't hear us, don't freak out. We're just switching out speakers. Talk to you guys in a bit.